Welcome to this explainer. I am so excited to guide you through what is honestly one of the most mind-bending and awe-inspiring achievements in human history. Today we're talking about the Voyager mission, but we aren't just looking at a spacecraft, right? We're looking at humanity's absolute longest journey. We're going to carefully unpack exactly how these twin probes, which launched decades ago, have completely redefined our understanding of the cosmos, pushing the very boundaries of engineering, science, and our place within the universe. 24 billion kilometers. That's over 15 billion miles away from Earth. Just to put that staggering distance into perspective for a second, it takes light itself, literally the fastest thing in the universe, over 22 hours just to travel from Voyager 1 back to our planet. These spacecraft have been traveling relentlessly, day and night, through the freezing, unforgiving vacuum of space. They've pushed past all our neighboring planets, completely left our solar neighborhood behind, and are now just totally alone out there in the dark depths of the cosmos. Okay, let's dive into this. How exactly is a nearly 50-year-old machine still talking to us from interstellar space? I mean, think about the technology we had nearly half a century ago. The smartwatch on your wrist or the smartphone in your pocket has millions of times more memory and processing power than the computers aboard Voyager. Yet somehow, this ancient, fragile piece of engineering is surviving extreme radiation, freezing temperatures, and the vast cosmic void, all while continuing to successfully beam scientific data back home. It's wild. Section 1. The Grand Tour begins, launching a 50-year journey. So, looking back at how this unprecedented road trip actually began, Year 0 marks the Voyager launch, back when the mission was designed with a relatively modest goal, honestly. Just visit Jupiter and Saturn. But jump to Year 10, and we see the execution of the Grand Tour, a brilliantly planned path utilizing a super rare planetary alignment that allowed the probes to visit 4 of our outer planets in one single swoop. And now, fast forward all the way to Year 50, and we see the ultimate destination, interstellar space. This timeline gives you a real sense of the mission's vast temporal scale. We are talking about a multi-generational achievement that has outlasted the careers of the very people who built it. Now, the secret to pulling off this epic trip was the gravity assist. By flying incredibly close to a massive planet like Jupiter, Voyager essentially stole a tiny bit of the planet's orbital momentum, slingshotting itself outward at mind-boggling speeds. This gravity assist trick is what made the Grand Tour possible in the first place, propelling the spacecraft way farther and faster than any conventional rocket fuel ever could. It was an absolute marvel of orbital mechanics. Let's move to Section 2 and see how this builds. The Deep Space Network, staying in touch. Traveling 15 billion miles is really only half the battle. The other massive challenge is actually communicating across that cosmic void. To bridge that gap, Voyager first sends a faint signal using a transmitter that operates on barely more power than a standard refrigerator light bulb. Let that sink in. That absolute whisper of a signal then travels billions of miles, spreading out and getting incredibly weak along the way. Finally, NASA's Deep Space Network catches this data on Earth. This network is a collection of massive, hypersensitive radio antennas situated around the globe. It is a sheer technological marvel that these huge dishes on Earth can just point at an empty patch of sky and capture these tiny whispers from the very edge of the solar system. Still communicating with Earth after nearly 50 years. I really want the gravity of this achievement to sink in for you. We're talking about half a century of unbroken conversation through the dark. Entire generations of scientists have grown up, worked their entire careers, and retired, all while these twin machines just kept flying and talking. It's an absolute testament to human ingenuity and the incredibly robust, flawless engineering of the 1970s that this fragile thread of communication remains totally intact today. Moving right along to Section 3, Beyond the Heliosphere, Crossing the Boundary. This brings our narrative out of the past and right into the present day. The heliosphere is the boundary region of space influenced by the sun. You can basically think of it as a massive, protective magnetic bubble created by the solar wind that shields our planets. Crossing it means the Voyager probes have physically left that protective bubble and entered the totally uncharted territory of interstellar space. They have broken through the veil. They are literally the very first human-made objects to ever experience the deep, mysterious space between the stars. So the crucial point here is that by crossing the edge of the heliosphere and entering true interstellar space, Voyager isn't just drifting aimlessly. It's making unprecedented scientific discoveries far beyond Earth. Because it's finally outside the sun's interference, it is actively taking measurements and sending back brand new data from a region of space that humanity has never, ever directly touched before. It is quite literally rewriting our astronomy textbooks right now as we speak. Finally, Section 4, Fading Power, Eternal Legacy, the final chapter. As incredible as this journey has been, and as much as we celebrate the triumphs of this engineering, we are facing a bitter, sweet, almost philosophical reality. The nuclear sources that power the spacecraft are slowly but surely decaying, losing wattage every single year. Very soon, they just won't have enough power to run the scientific instruments or even warm the transmitters. Yet, juxtaposed directly against this fading power is an enduring legacy, the golden records. We're essentially looking at the physical death of the spacecraft's power sources alongside the immortal afterlife of the messages they carry. These probes will be carrying the golden records through interstellar space long after contact is lost. I want you to really connect with what that means. These records represent humanity's collective fingerprint, etched with everything from the sound of a mother's first words to her child to the timeless rock and roll of Chuck Berry. Even when the spacecraft lose all their power, go completely silent, and freeze in the dark, they are going to continue to drift through the cosmos forever. They transition from active scientific probes into silent monuments to a species that dared to reach for the stars. Which brings us to our final thought. When contact is finally lost, who will find our golden record? Will it be millions or even billions of years from now? Will whoever finds it even understand what it is or where it came from? It's a haunting, provocative question, but it's the perfect way to wrap up our explainer today. The Voyager mission started as a scientific expedition to our neighboring planets, but it ends as a message in a bottle cast into the infinite cosmic ocean. Thank you so much for joining me for this incredible journey, and keep looking up.